Hi again. Now that I'm finished with the front crossbeam, I will start working on the back crossbeam. This will be a more simple structure to build because I plan to build it rather straight, meaning that the middle section will be straight, but the connecting pieces to the hull will be angled a little bit. So let's start with that. I have already cut strips when I did the front crossbeam, so I can start dry fitting them. I will build the side walls using 6 strips, 1 × 1 centimeter. This will give me enough height to carry the weight from 2 persons. As I want to keep the weight and the cost low, I don't want more material than necessary. I put masking tape on the back side to keep the glue in place and to keep the strips level with each other. Being happy with the fit, I can start gluing. Here I will use wood glue, as the gaps are smaller here than on the front crossbeam. It's also cheaper and less allergenic. If you join 2 flat surfaces with less than paper-thin gaps in between, it's just as strong as the wood. However, it's not water resistant, but as I plan on encapsulating the wood, it doesn't matter. What is important is that the gap gets very thin, as the glue has very limited gap filling properties. Thus I use a lot of clamps to get tight joinings. Although it looks like I might have overdone it here, but you can never have enough clamps. After a few hours I can remove the clamps, head outside and sand the surface level. I do this to prepare for later lamination, where a totally flat surface will need less epoxy to form a flat laminate. After sanding, I can as well cut down the excess. It's better to do this before I have put labor into this material. At this time I also dry fit the cross beams on the hull. I notice that I have made the hulls slightly different. The front towers, where the front beam rests, are about 53 cm above the ground. The port hull aft tower is only 52.5 cm above the ground. It's an okay difference to 53, but the starboard hull is 54 cm above the ground. The angle is also much larger for this tower, about 22 degrees compared to 18 for the port hull. I could of course redo the towers, but I don't want the extra work. Instead I decide that I will make the resting parts of the beam different for the 2 towers. Anyhow, this wall piece is too long, so I cut it down to the target length of 205 cm. I have taken off 5 cm from the theoretical half hull length to fit the beam inside my car. This will reduce the sail carrying capacity, but will also reduce hobby horsing. Now I head inside again, so that I can glue on material for the angle on the towers. This will be more than enough material to cut out the angled support from. In the other end I need less material. Outside again I trim off the excess on one side and measure out what to take off. And on the other side as well, so that it fits well on both sides. Inside again I can start adding the top cover on the beam. Just like before, I turn this into a clamping access. When the 2 side flanges has cured, I add the 2 strips in the middle. I smear out the glue on the joining sides. Then I put all together, carefully checking that the strips are level with each other before I add another clamp. The sides are not standing straight, so I clamp these as well and add some pieces to press the sides apart. After a few hours the glue has cured and I can trim off the excess. The angled supports give me some headache, but after a while I have figured out that I need to cut out a recess on the sides to get the bottom ready. Now I will be able to add the bottom without interfering with the angled supports. And I will be able to construct the angled supports independently later on. I need to plane off 3 mm on one of the strips to make the total width the same as the rest of the crossbeam. Now I can fit the bottom and draw lines over all 4 strips so that I can refit them in the exact same place. Now I can add the wood glue to these strips and start laying them together. I wear gloves here to protect me from the wood glue, otherwise it will dry out my skin. Having aligned the crossover lines, I can press the strips together, making sure that they are aligned both vertically and lengthwise. I finish with wiping off the excess glue. Outside again I level the inside. Now I start laminating with epoxy. I pre-wet the surface with pure epoxy before I lay down 160 gram per square meter glass fiber cloth. As soon as the first side has cured somewhat, I can turn the beam. To reduce the likelihood of air bubbles, I preheat the surface. Then I put pure epoxy on the surface. And as the surface is cooling, any voids will be easily filled with epoxy. Thus there are no air release from the voids in under the cloth during curing. Having a well-prepared epoxy layer without air, I can put down the cloth. The 90-degree bend can be tricky to take, but this cloth is rather forgiving. The twill structure in combination with the low density takes the bend, at least when it's an inside bend. As the wear and tear will be low on the inside, I can save weight and cost by using this thin cloth. Later during the night, before the epoxy is fully cured, I refill the cloth and turn the beam again to put glass on the third inside. Here I lean the beam so that the epoxy will not drop from above, but I still can work with gravity on this side. Of course, it's better to let one side get ready at a time, but I'm in a hurry for this week's episode to get ready in time, so that I also can get out sailing during the weekend. In the morning I turn the beam and refill the cloth on this side. Later in the day I clean cut the edges and prepare the surface for some additions. I introduce some tracks into the laminate to better bond. I will bond some 10 mm plywood as backing plate for hardware fittings. So I cut out material that fits in the beam. Of course I will need to cover this with glass as well. On this beam I also want to have a few holes for a line. I plan on using a circular line to move the sheet block instead of a traveler. It will be lighter, although the trade-off is a slight dislocation of the sheeting position. For the line I drill holes in each end. I will refill these with the glass fiber strengthened epoxy and re-drill them afterwards. I block one side with masking tape and start mixing epoxy for this afterfit project. First I glue the plywood pieces in place. As this can be done with somewhat thickened epoxy that also can be used to wet out the glass. Then I fill the holes with glass fiber cuttings and strike epoxy over it. As the epoxy is only slightly thickened, it still fills the void. And with some persistent strokes I get the glass into the hole. When all is in place, I let it cure overnight. The day after I can re-drill a watertight smaller hole in the laminate and trim it to smooth edges. I also put epoxy on the last side. By striking epoxy on the whole surface, I fill any voids before I put glass on the surface. This makes it easier to wet out the glass, but also decrease the risk of air bubbles. When all is wetted out, I let this pre-cure for an hour before I strike thickened epoxy on the receiving surfaces. Refill the cloth and put the parts together. By placing the already cured beam onto the curing surface, I avoid disturbing the curing surface. When I clamp the pieces together, I adjust the fit sideways with clamps before I add pressure vertically. This makes it easier to get a nice fit between the two parts. I check that the fit is nice before I move on. Now I have clamped everything well and can let the beam cure. The day after I can continue on the outside of the beam and laminate this side. This is only straightforward lamination, so let's roll over this quickly. After a couple of hours, when the laminate is still a little sticky, I backfill the cloth with thickened epoxy with some micro balloons added. This will give me a surface that will be ready for painting after a light sanding, that I do outside due to dust reasons. Inside again I have dry fitted the underside of the beam. I have crafted a few pieces of wood into resting supports, so I remove these on the pre-cut glass before I spread the epoxy onto the surface. As I need to buy more brushes, I use a rubber scrape to spread the epoxy, and only use a very small and last brush to spread the epoxy on the edges. Here I add 300 gram per square meter glass, using pure laminating epoxy to wet out the cloth. Then I add cotton fibers to thicken the epoxy and spread that where I will glue on the wood pieces. These wood pieces will form a resting support that fits with the towers on the hull. They do not need to cover the whole end surface, as most of the load will be carried by bolts going in sideways. Thus I can save some weight and material by only slope the sides. The area around the bend is covered with 160 gram per square meter cloth, as this will take the bend better. The support in this side is a little bit different. It slopes onto the beam without a jump, making the transformation nicer and smoother. In this end I will need to do some afterglassing to cover the end plate of the jump. I use up the leftover from this batch to refill the cloth. After a few hours I'm back to refill the cloth again. I continue in the same way with the remaining sides, pre-wetting the surface, applying the 300 gram per square meter glass fiber cloth, wetting out the cloth, refilling the cloth when the surface is sticky, and clean cutting the edges when the curing has gone further, until the beam is ready for painting. The result of this episode is a lighter, less expensive beam with about 90% of the strength compared to the front cross beam. Next time I will take you sailing with my canoe yawl. Please join me then.